Hello, welcome students. I am Rekha Thorat, Associate Professor. Today we consider some examples. Consider first example. Solve d2y by dx square plus y equal to cos of 2x. In the solution we write given equation and denote it as equation number 1. This equation 1 can be written as in bracket d square plus 1 bracket complete into y equal to cos of 2x, where d means d by dx. Auxiliary equation is bracket equal to 0, that is d square plus 1 equal to 0. Hence d square equal to minus 1. So we get d equal to plus minus I. Since square root of minus 1 means square root of minus 1 equal to I. Hence d equal to plus minus I equal to 0 plus minus I. That means roots are complex in the form of alpha plus minus I beta. Here alpha is 0 and beta is 1. We know that when the roots are in the form of alpha plus minus I beta, that is roots are imaginary or complex, then corresponding part of complementary function is CF equal to e raised to alpha x into bracket c1 cos of beta x plus c2 sin of beta x bracket complete. Hence, here roots are 0 plus minus 1. Hence, CF equal to complementary function equal to e raised to alpha is 0, 0x into bracket c1 cos of 1x plus c2 sin of 1x. That is c1 cos of x plus c2 sin of x bracket complete. But e raised to 0x is 1. So we get complementary function, that is CF equal to c1 cos of x plus c2 sin of x. Now we consider particular integral. Particular integral equal to 1 upon d square plus 1 operated on cos of 2x. And we know that d square plus a square operated on cos of 2x equal to minus x upon 2a sin of ax. Using this formula we get this particular integral. Thus we get this pi. Adding CF and pi, we get complete solution of given example. In this case, pi is found by using the formula 1 upon d square plus a square cos of 2x. Instead of this, we can find pi as pi equal to 1 upon d square plus 1 operated on cos of 2x. When the operating factor is cos of ax or sin of ax, then put d square equal to minus a square. Here a equal to 2. So minus a square means minus 2 square. That is minus 4 plus 1, which is equal to minus 1 by 3 cos of 2x. So that we get solution as y equal to ca plus pi as c1 cos of 2x plus c2 sin of 2x minus cos of 2x by 3 is the solution of given equation. Mostly we use this method. If there is any problem, then we can use this formula also. Now we consider after getting this solution, now we consider second example. Solve d in bracket d square plus 4 bracket complete bracket square into y equal to sin of 2x. In the solution we write given equation. Auxiliary equation is bracket equal to 0, that is d square plus 4 bracket square equal to 0. So we get d square plus 4 equal to 0, d square plus 4 equal to 0. Hence we get d square equal to minus 4, d square equal to minus 4. Hence d equal to plus minus 2i, d equal to plus minus 2i. That means d equal to 0 plus minus 2i, d equal to 0 plus minus 2i. That means complex roots are repeated. So we get complementary function as e raised to 0x into bracket c1 plus c2x cos of 2x plus in bracket c3 plus c4x bracket complete into sin of 2x bracket complete. Here e raised to 0x means 1. So complementary function is only this bracket. Now we consider particular integral. Particular integral equal to 1 upon d square plus 4 in bracket d square plus 4 bracket square operated on sin of 2x. Here a equal to 2. So put d square equal to minus 2 square. That is d square equal to minus 4 plus 4. So it will become 0. So we use the formula, the factor which becomes 0 by putting d square equal to minus a square becomes the factor d square plus 4 by putting d square equal to minus a square, that is minus 2 square. It becomes 0 and this factor is repeated 2 times which becomes 0. So we get particular integral as x square upon 2 factorial sin of 2x. This factor repeated 2 times, so we get this pi as x square upon 2 factorial sin of 2x. Adding CF and pi, we get complete solution. That is y equal to in bracket c1 plus c2x bracket complete cos of 2x plus in bracket c3 plus c4x bracket complete sin of 2x plus x square by 2 sin of 2x. Now we consider another example as solve d square into bracket d square plus 1 operated on y equal to sin of 3x. We write given equation in the solution. Auxiliary equation is d square into bracket d square plus 1 equal to 0. So we get d square equal to 0 or d square plus 1 equal to 0. Hence we get d equal to 0, d equal to 0 and d square equal to minus 1, that is d equal to 0 plus minus I. Two roots are real, two roots are complex. So we get here 0 root is repeated 2 times. So we get complementary function as c1 plus c2x e raised to 0x plus e raised to 0x into bracket c3 cos of x plus c4 sin of x. Since here alpha is 0, beta is 1. But e raised to 0x is 1. So we get complementary function as c1 plus c2x in bracket plus c3 cos of x plus c4 sin of x. Now we consider the particular integral. Particular integral equal to 1 upon d square into bracket d square plus 1 operated on sin of 3x. Here a equal to 3. So put d square equal to minus 3 square. So we get minus 9 plus 1, that is minus 8 and minus 9 operated on sin of 3x. So we get sin of 3x divided by 72. Adding CF and PI, we get complete solution. Hence the complete solution is y equal to in bracket c1 plus c2x bracket complete plus c3 cos of x plus c4 sin of x plus sin 3x upon 72. Now we consider case 3, that is particular integral when x equal to x raised to m. M is any positive integer. That means when operating factor is x raised to m. For example, x square, x cube, x raised to 5 and so on for x raised to m. That is where m is positive integer. Then particular integral equal to 1 upon fd operated on x raised to m. Here we write fd which is in denominator in ascending powers of d. It is in the form of 1 plus minus 5d. That means here when the operating factor is in the form of x raised to m, that is 1 upon fd operated on x raised to m, that is x for x square, x cube, then we write this fd which is in the denominator in ascending powers of d in the form of 1 plus minus 5d. Hence, particular integral equal to 1 upon fd, that is 1 plus minus 5d operated on x raised to m. Then we take this bracket in numerator. Hence, particular integral equal to in bracket 1 plus minus 5d bracket complete raised to minus 1 operated on x raised to m. For expanding the bracket, we use the formula 1 plus d raised to minus 1 equal to 1 minus d plus d square minus d cube plus d raised to 4 dash dash dash. And second formula is 1 minus d raised to minus 1 is equal to 1 plus d square plus d cube plus d raised to 4 plus dash dash dash. That is when there is minus sign in the bracket, all the terms are positive, and when there is plus sign, terms are alternative positive and negative. Another two formulae are 1 plus d raised to minus 2 equal to 1 minus 2d plus 3d square minus 4d cube plus dash dash dash. And 1 minus d bracket raised to minus 2 equal to 1 plus 2d plus 3d square plus 4d cube plus dash dash dash. Operating each term of expansion on x raised to m, we obtain the particular integral. Here we shall carry the expansion up to nth power of d, and also we denote that derivative higher than mth power. For example, d raised to m plus 1 of x raised to m equal to 0, and so on. Now we consider one example. Solve d2y by dx square minus 5dy by dx plus 6y equal to x. Here RHS side is x. We first write given example in the solution. Auxiliary equation is bracket equal to 0. Here sum is minus 5, product is 6. So we factorize as d square minus 2d minus 3d plus 6 equal to 0. So we get d into bracket d minus 2 minus 3 into bracket d minus 2 equal to 0. Hence in bracket d minus 2 into in second bracket d minus 3 equal to 0. So we get d minus 2 equal to 0, comma d minus 3 equal to 0. Hence d equal to 2, d equal to 3. So we get complementary function as c1 e raised to 2x plus c2 e raised to 3x, since the factors are 2 and 3. Now we consider particular integral. Particular integral equal to 1 upon d square minus 5d plus 6 operated on x. By theory, we write this fd in ascending powers of d. That is, we take constant outside, so that we write this fd in the form of 1 plus minus 5d. So we take 6 outside the bracket. So in bracket we get 1 plus d square minus 5d upon 6 bracket complete operated on x. Then by theory we take this bracket in numerator. So power is minus 1 operated on x, 1 upon 6 as it is. Now we expand this bracket by using the formula 1 plus d raised to minus 1 equal to 1 minus d plus d square minus d cube plus dash dash dash. Here operating power is x, operating factor is x, and derivative of x equal to 1. D square of x is 0. That means higher derivative of x more than 1 are 0. So only we take only these two terms, 1 minus d. So we get particular integral equal to 1 upon 6 into bracket 1 minus d square minus 5d upon 6 operated on x. Now we operate this x in bracket. So we get particular integral equal to 1 upon 6 into bracket x minus d square of x is 0 minus 5 into derivative of x is 1 upon 6. Bracket complete. To simplifying we get particular integral equal to x by 6 plus 5 by 36. Adding CF and PI we get complete solution as y equal to C1 e raised to 2x plus C2 e raised to 3x plus x by 6 plus 5 by 36 as complete solution of given equation. Thank you.